Hi again! As I promised in the last video, the part 7 of our tutorial will be focused on improving the player's ship. To enhance the overall gaming experience, we can introduce additional visual details, effects and functionalities to the ship. These enhancements will not only make the ship visually appealing, but also serve practical purposes. Importantly, many of these improvements can be extended to other objects within the game. By implementing these enhancements universally, we can create a more immersive and visually captivating experience for all elements within the game. We are developing a 2.5D game, so all object movement is constrained to the XZ plane with the Y coordinate consistently set to 0. In traditional 2D top-view games, the player's ship sprite merely changes its planar coordinates without undergoing any spatial transformations. However, in our case, since we are utilizing 3D models, we have the opportunity to add a touch of visual appeal to the lateral movements, left and right. For example, when an aircraft intends to change direction, it performs a roll maneuver, tilting one wing lower than the body while simultaneously raising the other wing. And that's exactly what we will implement in our game. Let's open the script player GD, there it is, and we'll add two new variables to the top, tilt and tilt direction. Both of them will be set to 0. Okay, so the variable tilt represents the ship's roll value, which corresponds to its rotation around the z-axis. A negative value indicates a left tilt, while the positive value indicates a right tilt. And the tilt direction, the purpose of this variable is to prevent the ship from abruptly changing its rotation. So, by setting it to either -1 or 1, determined by the x-axis velocity, we calculate the ship's tilt during each frame. This approach ensures a more natural transition in the ship's rotation over time, rather than an instant change. One more thing, to avoid excessive tilting like a barrel roll, we will establish a maximum tilt value. We will also use a function clamp f to ensure that the ship's tilt remains within the predetermined range. Let's implement everything what you just said to the function physics process. So if velocity x is a positive number, let's set the tilt direction to 1, or else if velocity x is a negative number, let's do it as a -1. Okay, and otherwise, if the ship doesn't move, we just revert the tilt direction. So if current tilt is positive, let's revert the direction, else if tilt is a negative number, tilt direction would be this is correct, and it should be negative here. Okay, else let's set it to 0. No tilt in this case. Okay, now we need to save the previous state to make sure that we handle crossing 0 between frames. Okay, what is here? Yeah, we missed a column. So we define a new temporary variable, tilt, saved tilt equals tilt. And now we add tilt direction to the current tilt multiplied by delta, so it's independent on the frames per second value. If saved tilt is positive and tilt is negative, or saved tilt is negative and tilt is positive, let's reset it. Okay, and one last thing. If tilt is greater than minus max tilt, this is a constant we didn't define yet, we will do it shortly, and tilt is less than max tilt, which means it will remain within the valid range, we perform the actual tilt rotation. Z is equal to tilt, and if not, we will set tilt as we mentioned in the beginning. Clamp F, tilt, negative max tilt, and positive max tilt. Okay. Let's set the max tilt to, let's try for example, I don't know, constants are here, so const max tilt is 2.0. Let's try it out, start a game and move the ship. Yeah, looks like it's changing. It's too much. It's almost a barrel roll, so let's make it, let's say 0.5 and check it. That's better. The ship is rolling and it looks like a natural movement. Okay. There is one more thing we can set to ensure that there will be no unexpected behavior. As we know, we are operating in the XZ plane. However, if a tilted ship hits the boundary with static walls, it could be, in theory, pushed slightly up and down over the y-axis. And to avoid that, we will set something called the axis lock. So we select the player's root node in Inspector. We find axis lock here in the physics body 3D section, expand it and set linear Y on. Now, when we try the game again, there shouldn't be any visual change because, as I said, it's already working as expected. But let's take it as a failsafe. Currently, we are employing a fixed speed for determining the ship's motion, which is a little bit boring. It would be better if we give players a chance to accelerate the ship occasionally. To achieve this, we can implement acceleration by pressing and holding the Shift key. So first, we will add a new custom action to project settings and input map. We will call it accelerate. Add, and we will assign the left shift key. Okay, now we need to implement this functionality in the script player GD. So let's start with a new constant for fast speed. Let's say 80. to make a real difference visually. And we need a new variable, shift pressed, which is by default false. And now we need to capture the user's input continuously. For that, we will implement the standard method function input, which takes a parameter event, and in this method we just make this shift pressed is true if input is action pressed accelerate, yes, else false. Okay, and now to perform the actual acceleration, we will create a new variable in the function physics process var speed is fast speed if shift pressed, else standard speed. Okay, now we need to replace all occurrences of this speed constant with the new variable speed. 1, 2, 3, 4. Is that all? Yeah, I guess it is. Let's execute the game and check it. Holding fast movement, releasing shift. I just died, but I think you saw that it's actually working. As you may recall, we designed our ship by assembling various modules. When we open the player TSCN scene, we can observe individual mesh instance 3D nodes representing each module. This modular approach grants us the flexibility to separate the modules in the event of the ship's destruction, allowing us to create a visually stunning effect. By sending each module on its own trajectory after the explosion, we can simulate the appearance of the debris, enhancing the realism of the destruction. So, we already have the function create explosion in the game manager. There it is. Now we will extend it and create a cool destruction effect. What we need to do is to get here after the sound of the explosion, and now let's add new functionality. If source node is in group modules, which means we will apply this destruction effect only to objects that are composed of modules. For example, an asteroid is not. This is just one mesh instance 3D. So if it belongs to this group, for module in utils get all children source node. This means that we will iterate over all mesh instance 3D objects found in this node as subnodes. And now, if module is mesh instance 3D, this is very important because we will add more. Oh no, we already have more child nodes that are not mesh instance 3D, for example, collision shape or area 3D, or just node 3D for weapons. And we want to apply this functionality only to the ship part. So this is why we have this check. And we'll call a new function, create debris from module, and we will use parameters root node and module. And one more important thing, source node and scale. This is also crucial because in Blender we scaled up or down certain parts of the ship. So if we don't use the original scale, the debris component would be just scaled to the default 111, and it wouldn't retain the original scale, as I said. So we need to pass this value as well. And okay, that should be enough, and source node Q3 will remain there. Now we need to implement everything what is new here. First of all, we created a new function getAllChildren in utils, but it doesn't exist yet because this function will iterate over all nodes recursively. So it should consider even nodes not only in the first layer, but anywhere in the node tree. Let me implement it. Okay, this is required for the recursion. Actually, this specific function is not related to the game creation at all. It is more like a programming exercise, which is why I don't add any detailed comments to that. Child in node. However, I don't think that Godot supports something like that, so that's why I implemented it myself. If, of course, in future versions they will allow us to get an array of all subnodes of the selected node, then it can be replaced, of course. Child array and return array. Okay, is that correct? Yes, it is. Very well, let's get back to the original script, game manager, and we need to create new function, create the debris from module. Let's do it here. Func, and the parameters should be root node, module, and scale. Okay, and the implementation. First, we need to duplicate the particular module, body, wings, engine, jets, weapons, anything else that could be found in the ship's model. And we will create a variable debris is module duplicate. Okay, the reason is that we will handle the debris asynchronously, and the original object would be already destroyed. So if we don't duplicate these modules, they would just disappear along with the original object, which we don't want to. Now we need to add it to a new group. Add to group, so we can again monitor the number of these objects in our debug overlay. This is very important because the number of these objects would be very high in case of many enemy ships on the screen and our ship destroying all of them in a short time range. So we will add it to the group debris. Now let's add some custom variables. This can be done easily by calling the standard function set meta, and we will call a meta value vector, which is basically the direction of this debris part to drift away, and vector 3, and we want to set it a random direction. Rand f range -1 and 1. Okay, this is the first coordinate, and in fact we can just copy and paste it to the other coordinates. Okay. Okay, looks like we have something wrong with the brackets. This is right. Yeah, this is too much. And again, now it should be fine. Is it? Nope. One more here. Damn it. What did I do? Ah, of course, vector parameters. I'm sorry. This should be fine. Ah, very well. And we will do a similar thing for the random rotation. Rotation, and we can keep it as it is. Now we need to set a timer, because sometimes if the random vector random direction and the speed is too low, the debris could just drift for a long time, and we don't want to have too many objects that don't do anything with the game on the screen. So we'll set a timeout. Debris set meta. Let's call it timer and give it the value 10. No longer than 10 seconds. Okay, now we need to apply the scale. Scale object local. And we want to set it to the correct position. Just where the original module was located before the ship at the time of the ship's destruction. Module global transform origin. Okay. And of course we need to add this newly created node to the node tree of the root. Root node, add child, debris. Okay. So we have the debris objects, but we need to move them as well. We only specified the parameters, but without the actual movement on every frame, nothing would happen. So we will add one more function, and we will call process debris. Let's put it below process background, because it would be called from the same place from the main script. Delta, and for, let's call it mesh in get tree, get nodes in group, debris, because we don't know how many nodes of this type we would have in the scene, so it's better to just iterate over all of them. Let's set mesh global translate the variable, the value we put into the meta object vector, multiplied by delta. And I think I've been doing some experiments and it was too slow, so I multiplied by 10 to make it a little bit better. Now we need to apply rotation, mesh, rotate, vector 3, and mesh get meta, rotation x by delta. I think I had some issues when I tried to apply all three axes at the same time, so I decided to separate it to x, y, and z. Now we need the unit vector here for y, and this is for z, and here we will do y and z, And we need to update the timer as well. Var time left. No. Yeah. Mesh is equals mesh get meta timer, and we subtract delta. So it goes closely to 0, and when it hits 0, if time left is negative or 0, or the debris module leaves the viewport, not is in boundary mesh. Let's get rid of this object, Q3, or update the meta property. Timer, a new time left. Okay, I'm pretty sure there are other ways to apply to implement this, but it works for me, so I think it can work for you as well. Anyway, feel free to improve this functionality as you wish. I'm pretty sure that it shouldn't be too difficult. Now we need to call this method from the main GD, where it is, here, and we will call it from process, of course, because it must be called on every frame. Game manager, process, debris, delta. Okay, nothing else should be there. And finally, we want the player's ship, which is currently the only modular object, to explode and break up after an impact with an asteroid. So the function that is responsible for this action must be amended in main GD as well. Let's find onPlayer destroyed. Here it is. And instead of just freeing the player's object, we will call game manager, create explosion, self, player, and let's give it a bigger explosion than the asteroid has. Instead of 15, let's make it twice as big. Okay, and this should be enough. One more thing remains. We must add the player's object to the group modules. Okay, let's give it a try. Can you see these parts drifting away? That's exactly what we wanted to achieve. It's still rotating. Now it's gone. Of course, I forgot to add the debris object counter to the debug overlay, so it's done. Now you can see it here, and the way I did it was just a standard one, nothing new here. Okay, now something about the debris. If the scene becomes overcrowded with the debris objects, it could potentially hinder gameplay by making it challenging for players to differentiate between active enemies and floating debris. To resolve this issue, a possible solution is to reduce the illumination of the debris instances, allowing them to blend with the space background. Let me show you how we can achieve that. Let's switch to the main scene, and we will add another light source. We'll duplicate our directional light 3D by pressing Ctrl D, and let's call it debris light 3D. Okay, now we will change a color of this light to something gray. Let's try this color for now. And we need to change the cull mask. Basically, this is a list of layers that will be illuminated by this concrete light. And because we want to use it only on debris, which is layer 10, we will deselect everything else. And we, of course, have to do a similar way with the main light, which is currently illuminating everything, so we just deselect 10. And one more thing, we need to add 2 lines to the function create debris from module in the script game manager. It should be here. Yes. So we will set layer masks debris, set layer mask value, and we want to deselect 1 and debris set layer mask value. We want to select 10. We deselected 1 because it is a default value for every new object, so it is no longer in the layer 1, it's in the layer 10. We should have everything we required, and let's check it in the game. Okay, and destroyed, and it is much less illuminated. Maybe we could do it even more gray, but it's up to you to experiment with that. Okay, so I did this experiment myself, and I think I found the right value for the debris light. Let me show you. And explode. Yeah, this is much better. I hope you can see something. If not, of course, you can change this value in your game as you wish. In the next video, we will finally do something about this heads-up display, which is currently not reflecting anything. We will add a shield to our ship and calculate the changes of hull integrity and shield power.